Hello friend, myself Sanjeev Dwivedi, and on behalf of Vidyalankar Institute of Technology, I welcome you all in this Java session. Now we are still continuing with multi-threading. In the last video that you saw for multi-threading, we have understood why do we need multi-threading. Like if a thread goes in, if a particular function goes into wait state or delay, then if we have someone who is mutually exclusive, we can make those functions to run so that the overall processor utilization can be improved. So let's see thread multi-threading language which can develop multi-thread program using Java. A multi-thread program contains two or more parts. They can run concurrently. Each part can handle different tasks at the same time, making optimal use of available resources, specifically CPU. The processor is the most prized processor. So we have to ensure that the processor is utilized to the fullest. Multitasking is when multiple processors share common CPU. Now, multi-threading extends the idea of multitasking into application. Like if my program contains, see, in that program that there was, we created a class A run and then class B run, and there was main also. Remember one thing: in every program, irrespective whether we specify or not, there is always one thread, and that is main thread. So if we try to understand the program that we discussed in our last session, it was something like this. We have main thread, and then it calls A1 thread, and then A1 sleeps, it switches to B1, and between A1, B1 and main. So my processor keeps on switching from main to A1, A1 to B1, B1 to A1, A1 to main, main to B1, B1 to A1, A1 to B1. But there is no fixed order. So here we have all these three processes running parallel to each other. So that's multi-threading. Now, here, what we have is each of the thread can run in parallel. The OS divides processing time not only among different applications, but among each. I mean, see, these are three threads of the same application. So when it is not multiprocessor. Remember, we will see the difference. It is not multiprocessor. It is multi-thread. Now, when I say multiprocessor, I mean we are talking about different CPUs, different set of CPUs, each running different tasks. Here, what we have is we have divided a big task into small number of subtasks, and these subtasks are mutually exclusive to each other, and we made them run in parallel. Let's see the comparison. Multiprocessing and multi-threading. In multiprocessing, we add CPU to increase the computing power. Here, what we do, we divide our main application into small number of threads so that they can run parallel to each other and can improve the overall computing efficiency. Here, multiple processes are executed concurrently. So there are two different processes that are executing. Here, tasks of same process are executing concurrently. When I say multiple thread, means they are tasks of the same process or same application. Here, when we create a new process, it is time consuming. I mean, if you might have studied OS, then you must have this idea. When we create multiple or we create new process, it is time consuming and resource intensive. But creating multiple thread is economical as compared to creating multiple process. And it can be symmetric, unsymmetric, and threading is not such classified. So try to understand, when we add a new CPU, it's multiprocessor. When we divide or bifurcate or big tasks into small number of subtasks that are mutually exclusive to each other, it's multiple threading. Now these are now we're going to talk about life cycle of a thread. Very interesting. Here we have life cycle of a thread. Now it's like when we create a thread object. When we create a thread object, a thread is said to be in newborn state. Now suppose I created thread T1 equals to new thread. I created a new thread object. As soon as you create a new thread object, we say that the thread is in newborn state. Now in this state, the thread is not scheduled for execution. In this thread, the thread is not scheduled for execution. It is waiting for it to be activated. Now, if you can recall, we all see the method where we implemented the thread logic was run, but the method that we called was start. Now, why so? We never called run method. Now, if we call run method explicitly, it will not be multi-threading. Now, why so? Let's see. So what you do is you created a thread object, your thread is in newborn state. Now, when you execute a start method, now you activated your thread. Now your thread is in runnable state. Now in runnable, as it is waiting in a ready queue for processor allocation. You just activated your thread, and pushed it into ready queue. And inserted it into ready queue. Now the thread will wait for its turn for processor. As soon as it gets the processor, it will run. Now the thread continues to be run, or continues to be in runnable or running state. There is running state here, runnable, running both. Now we can block the thread. How? If we block the thread using sleep method, we specify the time in millisecond. My thread will remain blocked for specified number of millisecond. Once that millisecond lapsed, it will go back to runnable state. Means it will go back to the ready queue. A processor has ready queue that contains all the process or threads that is waiting for processor allocation. So once a thread is in runnable state, it will have processor allocation, it will run. We can block a thread using sleep method, or we can block a thread using suspend method, or we can block a thread using wait method. Okay. Now this will cause thread to be in a block state. If the thread is blocked due to sleep method, after the time lapse, because in sleep method we will provide the time lapse. After the time lapse, it will go back to runnable. Now, if a thread is blocked due to suspend method, we have to call a function called as resume to reactivate the thread and send the thread to runnable state. If the thread is blocked due to wait method, then we have to notify. Now, if a thread is due to sleep, after time lapse, go back to runnable. If it is suspended due to suspend, after resume method, go back to runnable state. If it is blocked due to wait, after time lapse, we'll go back to runnable state. Now this is what will happen. So so this is about block state and running state or runnable state. Now, if a thread continues to finish the execution, like in my run, I have written for I equal to 1, I less than equal to 10, I plus plus, and 10 time display hello. So after 10 time displaying hello, my thread will enter into dead state because the work is done. We say the natural death of a thread. We call it as natural death of a thread because the thread has completed its execution and then enters into dead state. However, at any point of time, we can kill a thread. If it is in born state, runnable state, or block state, we can kill a thread using stop method. That will cause the thread to enter into dead state. So this is about life cycle of a thread. Let's see. See, newborn state. When the new thread object is created, the thread is said to be newborn state. In this stage, the thread is not yet scheduled for execution. Runnable state. A thread is scheduled for execution by invoking start method. So it is start method that actually activates a thread. Here the thread will enter into runnable stage where it will wait for execution in ready queue of the processor. Actually runnable and running together forms an active state. It's something like this. It is active state. In active state, we have runnable, and then we have running. So when a thread is activated using start method, it goes to runnable state and it continues to stay here. Thread in runnable state means waiting for processor allocation. It is in ready queue. Now, as soon as it gets the processor allocation, it will enter into running state. Now, suppose thread is in running state and a higher priority thread comes and request for processor, then my thread will voluntarily hand over the control. And if it do so, it is done by using yield method. Now, normally what happens when a thread loses the processor, the thread goes to block state. The thread goes to block state. But what happened here, if a thread is in running state and another high priority thread comes and requests for processor and my thread voluntarily hand over the control, that thread will not go to block state. The thread will using yield method, it will be done and my thread will go back to runnable state. So after running directly, it goes to runnable state and it will again wait for it turn in ready queue. So this is about runnable and running. No. Block state. A thread can be blocked by using sleep, suspend, or assume. Thread in block state is not dead, but it's not yet scheduled for execution. So basically, it's not working thread, currently not working. And in dead state, a thread may enters into dead state after it finishes the task, or it can be killed using stop method. So this is about life cycle of a thread in a nutshell. It's like when we create, remember now you must understand the sequence. We created a thread object and we called start method. We never called run method, because once you call run method explicitly using thread object, then it will not be a multi-threading, then it will be a normal function call. So this is about life cycle of a thread. We will study the thread details in further videos. And for deep study of this, you can refer Java to Complete Reference by Herbert Schmidt. Thank you very much.